Welcome to our new unit on atmospheric pollution. We've discussed some energy choices and energy situations that might be valuable to sustainability and best achieving our conservation and our energy efficiency in the future. So now we need to address some problems of pollution by seeking ways to avoid all this stuff in the first place. We'll require less energy and fewer resources if we clean all this up. Preventing pollution is usually much less expensive and energy intensive than it is controlling pollution. But unfortunately, pollution prevention is not always possible. So we're going to talk about some strategies and techniques for controlling sulfur dioxide and nitrogen oxides and particulate matter. And we're also going to describe some innovative pollution control measures that are now in place. As with other types of pollution, the best way to decrease air pollution emissions is just to avoid them altogether in the first place. And this can be achieved through the use of fuels that contain fewer impurities. Coal and oil are a good example because they both occur naturally with different sulfur concentrations, and they're available for purchase at a variety of sulfur concentrations anyway. And during the refining process, the concentration of that sulfur can be reduced in all the fuels. So the use of low sulfur coal and oil is certainly one of the best ways to control air pollution. Although typically low sulfur coal and fuel are more expensive to purchase, they also contain that higher sulfur concentration is it's expensive to get it out of the oil in the first place. All right, so there's other ways to reduce air pollution and increase efficiency. So the use of less fuel and basically less fuel just in general will produce less air pollution, and use these measures to reduce emissions in certain amounts. So wherever fuel is full of it or not, if we reduce combustion, we'll reduce pollution. So ultimately, the most important attempt to reduce air pollution will depend upon how we control the pollutant's combustion process. And there's a number of approaches to doing this. So sulfur and nitrogen oxides are common air pollutants in the United States, and they cause a variety of environmental problems, as we've discussed before. But substantial number of air pollutants control measures have been directed towards sulfur and nitrogen oxides specifically, because sulfur dioxide emissions from coal exhaust can be reduced in the process known as fluidized bed combustion. I hope I said that right. This process, granulated coal is burned in close proximity with calcium carbonate, and then the heated calcium carbonate absorbs that sulfur dioxide and produces calcium sulfate. And that can be used in the production of it's gypsum, I guess, or wallboard, also known as sheetrock, and used as building materials. And our local power plants do this. Over 35 years ago, in 1975, all new automobiles that were sold in the United States were required to include a catalytic converter, and that reduced the nitrogen oxide and carbon monoxide emissions almost overnight for all the cars that were purchased. And in order to operate properly, the precious metals inside of the catalytic converter, which is mostly made out of platinum and palladium, cannot be exposed to lead. So therefore, gasoline could no longer contain a lead. And we'll see the significance of that here further. But in addition to that, we started to use baghouse filters, and we also started to use electrostatic precipitators. So we're going to talk about these things a little bit more individually here in just a sec. Now that helped a lot of the NOx and SOx, but what about this particulate matter? The removal of particulate matter is most commonly a means of pollution control, and so sometimes the process of removing particulate matter, it's a bonus because it also removes sulfur. So there's a variety of methods on how particulate matter is removed, but the simplest is a gravitational setting, in which relies on gravity as the exhaust travels through a smokestack. These particles simply settle out to the bottom, and then the ash, that residue that is accumulated, is scooped up and deposited in a landfill. And depending upon the fuel, that is required, it might actually, or the fuel that's being used, it might have to have a special type of disposal. All right, but pollution control devices remove particulate matter in another forms after combustion, and each of this has its advantages and disadvantages when it comes to actually making energy. The most common being electricity. Electricity, when we make it, it generates even additional pollution. Fabric filters are one type of filtration device that allows gases to pass through particulate matter, and these are often called baghouse filters. They're made out of a certain fabric, and they can remove almost 100% of particulate matter. An electrostatic precipitator, that's used as an electrical charge. It makes electrical charge particles so that they can be removed. Polluted air enters the precipitator, and then an electrical charged particles within it, they're attracted to those negative and positive charged particles, and then they collect along the sides of the precipitator, hence the name precipitator. The particles that are collected are relatively clean, and so the precipitator can be cleaned out, much like the smokestack. Now, the scrubber is this unique invention shown here, and a scrubber is shown. It uses a combination of water and air that actually separates and removes particles. So particles are removed in the scrubber in like a liquid or like a sludge, and in that type of form, and then clean gas exists from that. So, borrowing from the concept utilized in the electrostatic precipitator, particles are sometimes ionized before entering the scrubber to increase efficiency. So, scrubbers are also used to reduce emissions of sulfur dioxide. All three types of pollution control devices, because they use additional energy and they increase the airflow resistance in a factory or in a power plant, they require the use of more fuel. As a result, that also increases carbon dioxide emissions. So devices like the electrostatic precipitator and the scrubber have helped reduce pollution significantly before it's actually reduced in the atmosphere. It's much harder, if not impossible, to remove pollutants from the environment entirely, especially once they've been dispersed over the world. But scrubbers are a new addition to a lot of power plants, and they're very proud of them. And many power plants install multiple scrubbers. You'll hear them talk about them a lot on newscasts and such, because as they're built and installed, they are changing the way that air quality is coming out of almost all power plants. A number of cities around the world, including those that are in China and Mexico and England, have taken innovative and often controversial measures to reduce smog levels. Some municipalities have passed measures to reduce the amount of gasoline spilled at gasoline stations. Some restrict the evaporation of dry cleaning fluids, or even restrict the use of lighter fluid in general. Even for charcoal to start barbecues, that they have put laws against. But both urban and suburban areas have taken additional actions, like calling for the reduction in the use of wood-burning stoves or even fireplaces. And, I don't know if fireplaces are going to reduce emissions overall, but it does contribute to lessening nitrogen oxide and also particulate matters. A number of California municipalities had even discussed reducing the number of bakeries within a certain area, because the emissions from rising bread contain those VOCs that we talked about. And this proposal was, not very popular, as you can imagine, but emissions from bakeries, along with many other businesses, are sometimes regulated by local air quality ordinances. And usually that goes through, in the state of Georgia anyway, through the DNR, by ambient monitoring units. But since cars are now more reasonable and they've lessened their emissions of NOx, SOx, and VOCs in urban areas, there are two compounds that are more contributing to smog formation that we need to really focus on. And those usually are nitrogen oxides and the VOCs. A number of cities like Mexico City, they've instituted plans and permitting automobiles to only be driven at some point during the day. So, for example, the license plates ending with odd numbers may only be used on one day, and those with even number license plates can only be used on an alternating day, which sounds very foreign to us. In China in 2008, when they hosted the Olympics, the Beijing Olympics, the government successfully expanded public transportation networks, imposed motor vehicle restrictions, and temporarily shut down a number of industries as a way to reduce all that photochemical smog that that the country was leaking, and that just improved visibility in a substantial way just by that one event. So limiting automobile use has also helped reduce air pollution just in general. So like the carpool lanes, the available in available areas, and also just reducing the number of cars on the road in general, or encouraging two or more people to ride together. Improving the quality and accessibility of public transportation encourages people to leave their own cars at home. So, a number of cities in England, even London, have been experimenting with changing industrial user fees or like tolls on the actual road. And this would encourage or limit the times of day when certain parts of the city will be open and other parts will be closed based on traffic. And road user fees have been proposed even in the United States and really even New York. Not many of them have been implemented yet. But again, in 1990 and in 1995, scientists and policymakers and lots of academics included certain amendments to that Clean Air Act that are going to now allow for free market to determine the least expensive way to reduce emissions and sulfur dioxide. This free market program was implemented in two phases, in 1995 and then again in 2000. And approximately 3,000 power plants are now covered under the acid rain program. So far, each phase has led to significant reductions in sulfur emissions. One of the most innovative aspects of the Clean Air Act amendments was that the provisions for buying and selling all of these allowances that were authorized by owners. So, in a sense, companies can purchase another company's pollution allowance, if you will. Anyway, the overall economic cost of achieving all of these reductions has been about 1/4 of its original estimate, and that's good, even on the U.S. and global scale. So, global change researchers have used this sulfur allowance example to model a more recent experiment in buying and selling carbon dioxide allowances. We're going to discuss that later. Is the discussion worth using a capital allowance to solve our carbon crisis? We'll find out here shortly. From this unit, you should be aware that you need to be able to explain the purpose of a sulfur allowance and how it works. And so a sulfur allowance grants the holder the right to release a certain amount of sulfur dioxide in a given year. And so these allowances can be bought and sold. And if emitters want to exceed their allowance level, they must purchase more allowances from another source, like a company. And if a company decreases its sulfur emissions, it can sell its unused emission allowances, which is slightly messed up, but that's how it works. And so the ability to sell an unused allowance gives companies an incentive to emit less sulfur. So over time, the number of allowances distributed each year has been reduced and then reduced and reduced slightly, which makes the sulfur allowance even more valuable to those who can sell it off.